For the following core network and everything connected to it for a mid-sized city, I'm going to explain the following PDF that I've uploaded. For the first part of the problem one, talk about the core network, access networks, and the network core structure. For the core network, I wanted to use a general fiber optic cable to connect it all across, and using a multiple protocol system using packet switching across the majority of it. It'd be placed in a ring topology system to allow all of them to be connected across each other, and any outages would allow them to skip by the ones that have been disconnected. From a majority of the core network itself, multiple protocol system would allow general connections across them all, with a connection to outer areas like external networks, while IS for the internal systems themselves. For the access network, which would be used for residents, businesses, and government officials and organizations, there would be two separate sections connected across them, with main homes and residents being using fiber systems, like fiber to the home, along with some small wireless areas if they're not able to afford or connect fully across their less urban areas. The businesses and governmental organizations, though, will be using mostly fiber for across all of them, in wider 5G, 4G LTE systems to use mobile users across the entire city. Now, priority would be the fiber system across all of this, but if they're not able to, they're due to budget constraints or anything else, placement of businesses and everything, then there's, of course, the wireless systems as well. The network core structure, though, itself would be primarily used as ring topology in order to get it fully connected across and allow network caches across them all to have users' data at each individual parts across this huge ring instead of having to go through all. For bandwidth allocation, we need an efficient way of transferring data across everything in huge bulks, and also in lower efficiency speeds. The lower efficiencies would be using a quality of service framework to see what traffic-based applications need and go across with higher priority, while the huge bulk data transfers mentioned before would be on a very low priority in order to free up more resources across everything. Dynamic bandwidth management using software-defined networking is a good portion of what we'd be using here, as it would divvy up everything as it sees fit across it and use the most efficient route. The cost efficiency of this is lets us have wireless and also the fiber separate, and along with having those ones being the main priority, while the wireless being second to that, though. The reliability, though, of all of this is the fiber optic cables connecting everything being the main priority, and since it is using a ring-based topology, if some parts have outages, this will allow others to make up for the slack of where they are. Data caches data edge caches in order to take up where other users' data are without having to go through the entire system. And then in general, content delivered networks from all that, just using quality of service mechanisms to prioritize whatever is critical and needed the most. Trade-off, though, is budget constraints and mobility across how all these places are able to set up fiber systems and wireless. So that is the biggest part, and that just comes into who can afford what across the whole system. But this should divvy up all the resources without getting too much abnormal issues.